Good morning, everyone. Good afternoon, based on your location. So this is Wasim Gadban. I'm the Global Vice President for Innovation and Digital Engineering at Kent. Little bit about our organization. Within Kent, we are integrating a portfolio of industry leadership and expertise. We have professional engineers and digital innovators delivering excellence every day with the heritage of industry-leading brands. Kent is a fresh, new integrated energy player who design, build, and maintain the assets that power the world for today and makes it future ready for tomorrow. Our core services, advisory, digital engineering, conventional engineering, projects, completion and commissioning, operation and maintenance. We have executed projects in more than 80 countries, and our ambition is to become the global leader in integrating energy services driven by sustainability and innovation. Well, about our digital services, so we are a system integrator, we are a digital consultant, we are helping our clients to achieve the goals by implementing properly digital solutions. We are pioneers in the digital twin. We have a great experience in implementing digital twin to design and define the proper functionalities for digital twin suitable for our client needs. This year, we delivered many projects in digital twin, and we have a big list of credentials delivered not only in oil and gas and energy sector, but also in infrastructure and other sectors. This year, we delivered the most advanced digital center for ADNOC. It's called ADNOC IWC Panorama, which is based on digital twin, where we have integrated all solutions under the umbrella of the digital twin to show the real-time information from the assets portfolio. Also, part of that solution was to integrate with virtual flow meter based on AI and the safety solutions, what we call AI geofencing. All of these solutions were integrated under the digital twin to give the holistic approach for the entire operations of ADNOC. Also, we are working this year with Aramco in implementing digital twin at the field stage. And today, I'm going to describe the different phases of the digital twin and the values. Why do we need digital twin? So if you tell your management that you can reduce unplanned shutdown by 75%, cut the duration of plant turnarounds by 50%, and extend asset life cycle by 10%. We have heard a lot about how digital twin can provide visibility during engineering and construction, but today I'll go more and describe the real solutions that you can achieve and the real value that you can achieve through the operations. Well, let's take a step back and look to our industry challenges. We always hear the same question: where to find information? What is the progress of my project? Is it accurate? I don't have access. I was not aware, especially when there is a problem. In which system? Why it's down? Are we getting bad values? Who's in charge? What if? What happened? And mainly all these questions because we have lack of integration between existing systems. We have lack of sharing information. We don't have the right information available to the right team at the right time. So in oil and gas in specific, we know that digital twin will drive the Industry 4.0 initiatives and unlock the next wave of innovation. These innovations actually is to address the challenges that we are facing, the challenges that I've listed. Digital twin is coming under the spotlight as a significant driver for business value to overcome all challenges, and especially the challenges right now related to COVID-19. There are various definitions, concepts, and platforms for digital twin in the market. But the good thing is that our goals are always the same. We all want to reduce cost, enhance safety, optimize operations, increase production, reduce downtime, and definitely reduce emissions. So what is not probably clear to many operators that the value that digital solutions can provide for the entire life cycle of oil and gas field. What is helping us these days is the advanced technologies, right, to capture more data, analyze them, to move toward digital assets. Talking about IoT devices, AI cameras, high power computing, machine learning, data sets, 5G, robots, satellites, drones. All of these technologies are helping us to have more insights of the historical data, to capture more data, to have a quality of data, to better develop what we call the digital asset. So what is the roadmap to unlock all this real value? What's the roadmap? To be able to achieve the ultimate goal of oil and gas, which is autonomous operation, right? We should have a roadmap. So this roadmap is a set of milestones that we need to achieve. And we have defined this roadmap based on what we call maturity levels of digital twin, which the levels that defines the link between the physical environment and the digital environment. So whether you have one-way integration or two-way integration or fully synchronized. A feasible approach will be to look at the digital twin as a roadmap, which can increase financial benefits throughout its evolution. The digital twin roadmap must focus on creating business value at every step through better integration across various technical disciplines, organizational functions, and key players in the value chain. Well, so what is the framework? The digital twin is an ecosystem of asset life cycle where data gets real and matured as we move toward operations phase. It's an ecosystem of asset informations, tasks, and processes simulated and displayed in the digital context for an integrated project execution and unified and predictive operations. So this is the ecosystem, right? We want everyone to be part, all the stakeholders of the project and all the operations team to contribute in the development of this ecosystem. It's like a Google map, like all the information that we find there is actually published by us, whether it's traffic information, real-time information, or information that we upload related to outlets or places. So take the approach of digital twin as the approach of layers to move from static information to real-time and dynamic information. So for us in oil and gas and energy industry, the 3D model is always the foundation to develop a digital twin. A 3D model or point cloud. So I know that many aging assets, they don't have a 3D model. So we can help them to convert from the point cloud by the laser scan to a 3D model or from the 2D to 3D. But it's very important to display the information in the context. And to be able to do that, we need the 3D model to be the foundation of the digital twin. The best way to start really at the feed stage, to start to build these values, to start to build these layers, right? So during design phase, the engineering data increase as the feed proceed. Data are increased as engineering activities proceed. Engineering data are updated to reflect as build status. Real-time operations data are integrated in the digital twin. Engineering data maintained as operated. Live streaming is a layer to monitor operations data. And operational historical data will provide the analysis and insights and can be used for unmanned and autonomous operations. So this progressive approach, as I said, we always recommend to start the digital twin at the early phase. Whether you need to plan properly digital twin, you need to define what you are trying to achieve, right? Because we have seen many failures. Many programs, many projects in digital twin failed to achieve the goals because it was not planned properly. And so we always recommend to start at very early phase to define the functionalities. We can recommend to the best step and the best phase for the asset life cycle, start at the feed, then proceed with the digital engineering, construction, operation, and maintenance. And in each step and in each phase, we integrate with existing systems. For instance, during engineering, we integrate with document control system, we integrate with design tools, whether it's like SmartPoint, PRD, or and the 3D models, the modeling tools that we have. We integrate with P6, the scheduling tools. We integrate also with progress during construction to be able to simulate the progress in 4D, 5D. We integrate with safety tools and the work permit. So all of these to complete the EPC. Then during operation, we start to talk about the integration with real-time information from the DCS, from the historian, or from the CTV system for live streaming. We integrate as well with LIMS and GIS to be able to form this ecosystem. So we consider the digital twin at the end is the brain of data to read from all the systems and to give insights to the audience based on their needs. So all of these will lead us to what we call and the 8D digital twin. So our approach and our definition to digital twin is summarized by these 8 dimensions. It's not the beam that we see in infrastructure. It's more specific for energy and oil and gas business. And this will define the dimensions that we need at the equipment level. So what do we mean by that? So if, for instance, if you take like a pump in an operating plant, 8D digital twin will provide remote operators and AI autonomous models with all data captured in the project lifecycle by different systems and tools in different timelines. For instance, you will have all the specification for this pump. You will have the data sheets, you will have the PNIDs, you will have the PFDs, you will have the equipment list, you will have the 3D model, the point cloud if you don't have a 3D model. You'll have the GIS coordinates, you'll have information about cost, risk data, installation and maintenance schedule, real-time operations data, whether pressure, temperature, vibration, spare parts available in the warehouse, work orders from maintenance and operations team, work permit, and the live streaming from satellite or CCTV. And the last part, which is the 8th dimension, what we call a predictive portfolio of an equipment, which is very, very important to achieve predictive operations of your assets. So all of these combined in the digital twin at the equipment level will give you a single source of truth to reduce downtime and optimize operation process. Again, the same goal can be achieved by this model is the right information available at the right time to the right team and for AI. So let me give you a few examples about digital twin. This is a digital twin, for instance, for operation. You can see like the work orders issued by any system that we have. It's very important that to consider the digital twin is the system of systems. So you don't need to remove the existing systems rather than reading data from there. So these work orders are generated from Maximo, I believe. And we simulate the process graphics in the digital twin. You can see the faceplate at the equipment level. So you can see the real-time data. You can see the performance of each equipment, pressure, temperature. So this is a great solution for operation. And definitely you can add more modules to, for instance, like predictive modules and other modules related to your operations and maintenance. This one is digital twin for design, whether it's for field or detail engineering, where we have integrated all design tools with document management system. And we developed what we call the class library to be able to see the compliance and completeness of tags. And we integrate also with schedule and with a cost, with the supply chain, with everything related or developed by the engineering team at this stage. So all of this is giving us a 5D digital twin suitable to enhance the design review of the field, the design review of detail engineering, and digital review actually of detail engineering, and will help also contractor to see exactly what they have to do during construction. So in this, again, like functionalities can be customized based on the needs. So after you have all this digital twin information available in your solution, you can visualize, you can create like what we call visual queries to see the information directly in their context. So you can retrieve like the equipment, you can search by system, you can search by pipeline, so based on your needs. It's very important that we differentiate between digital twin and digital twin experience. So digital twin experience is how we consume the information of digital twin, right? Whether like you're using a desktop, you're using a tablet at site, or you're using like HoloLens, when looking to the equipment, physical equipment, to overlay that equipment by digital information from digital twin, or like in the video wall, like what we see right now in the digital centers, like what we have in Dhahran, Aramco Dhahran, and in Panorama, ADNOC Panorama, or the centers that we developed and delivered this year, the IWC. Also, it can be used by, the information can be used by VR and AR for training purposes, right? So there are different ways to consume this information. The ultimate goal is to consume the historical information of digital twin by the AI autonomous engine. The biggest mistake I see these days is considering digital twin as one solution fits all purpose, right? It's been said that the digital twin is a replica of physical asset, but please don't wait till you have a physical asset built to have a digital twin. As Values covers project and operations of assets. So during project, we talk about like design simulations, talking about like enhancing our design by automation, talking about immersive design review, about data-centric unified engineering. All these solutions are achieved by digital twin implementation at the design phase. For construction, it's more about enhancing the safety. It's about achieving real-time progress 4D, 5D. For operations, as you see, there is a big list. It's mainly about asset performance management and supply chain, connected workers, predictive and prescriptive analysis, integrity management, immersive training. And the list goes on as we move toward digital assets that will contribute to the development of smart cities and the global ecosystem where everything is synchronized and integrated. Thank you.